Fixture wire is a specialized type of electrical wire designed for use within lighting fixtures and similar appliances. It's typically composed of stranded copper conductors, providing flexibility, and features a relatively thin layer of insulation compared to general-purpose built-in wire. The specific requirement addresses the permissible use of fixture wire in conjunction with branch circuits rated at 20 amperes. It states that fixture wire can be tapped or connected to the branch circuit conductor of a 20 ampere branch circuit or one with a higher amperage rating, provided that the fixture wire itself is 14 American wire gauge or AUG or larger. In simpler terms, you are allowed to connect fixture wire to a branch circuit that has a 20 ampere overcurrent protection device or a higher amperage rating, as long as the fixture wire meets or exceeds 14 AWG in size. This rule is significant because it allows for the connection of lighting fixtures, which often use fixture wire internally, to standard branch circuits commonly found in residential and commercial buildings. Without this allowance, it would be necessary to transition to a different type of wire before connecting to the branch circuit, adding complexity and cost to the installation. Now let's delve deeper into the implications and considerations surrounding this requirement. Firstly, it's crucial to understand the concept of a branch circuit. A branch circuit is the portion of an electrical system extending beyond the final overcurrent protective device, such as a circuit breaker or fuse, protecting the circuit. It's the circuit that directly supplies power to outlets, lighting fixtures, and other electrical loads. The amperage rating of a branch circuit, such as 20 amperes, indicates the maximum amount of current that the circuit can safely carry. Secondly, the American wire gauge, or AUG, is a standard system for designating the size of electrical conductors. The smaller the AWG number, the larger the conductor's diameter and the greater its current carrying capacity, also known as ampacity. A 14 AWG copper conductor, for instance, has a higher ampacity than a 16 AWG copper conductor. The NEC specifies the allowable ampacities for different wire sizes and insulation types in Table 310.15b16. Thirdly, the term tap refers to the method of connecting the fixture wire to the branch circuit conductor. This connection must be made in a safe and reliable manner, typically using approved wiring methods and connectors. Common methods include wire connectors, such as twist-on connectors or push-in connectors, and terminal blocks. Now let's consider some practical examples. Suppose you are installing a series of pendant lights in a kitchen. Each pendant light uses 18 AWG fixture wire internally. The branch circuit supplying these lights is a standard 20 ampere circuit. According to the rule, you cannot directly connect the 18 AWG fixture wire to the 20 ampere branch circuit conductors. You would need to use a junction box and transition to a larger wire size, such as 14 AWG or 12 AWG, before connecting to the branch circuit conductors. However, if the pendant lights use 14 AWG fixture wire internally, you could directly connect the fixture wire to the 20 ampere branch circuit conductors, provided that all connections are made properly and in accordance with the NEC. Another scenario involves installing track lighting. Track lighting systems often use fixture wire to connect the individual light fixtures to the track. If the track lighting system is supplied by a 20 ampere branch circuit, the fixture wire used must be 14 AWG or larger. This ensures that the fixture wire can safely carry the current without overheating or posing a fire hazard. It's important to note that this rule applies specifically to the connection of fixture wire to branch circuit conductors. It does not apply to the internal wiring of lighting fixtures or appliances, where smaller gauge fixture wire may be permitted based on the specific application and listing requirement. Furthermore, it is crucial to consult the NEC and local electrical codes for the most up-to-date requirements and interpretations. Electrical codes are subject to change, and local jurisdictions may have additional requirements or amendments. In addition to the wire gauge requirement, there are other factors to consider when connecting fixture wire to branch circuits. These include the temperature rating of the wire, the type of insulation, and the ambient temperature. The NEC provides detailed information on these factors in Article 310, Conductors for General Wiring. The temperature rating of the wire indicates the maximum temperature that the wire can withstand without degrading its insulation. It is important to select a wire with a temperature rating that is appropriate for the application and the ambient temperature. The type of insulation also affects the wire's ampacity and suitability for different environments. Common insulation types include thermoplastic high heat resistant nylon coated, or THHN, thermoplastic heat resistant, or THW, and cross-linked polyethylene, or XHHW. Each insulation type has different characteristics and is suitable for different applications. The ambient temperature is the temperature of the surrounding air. The ampacity of a wire decreases as the ambient temperature increases. The NEC provides correction factors for ampacity based on ambient temperature in Table 310.15b2. When installing fixture wire, it is important to follow all manufacturers' instructions and recommended practices. This includes using the correct tools and connectors, making proper connections, and ensuring that the wire is properly supported and protected from physical damage. Improperly installed fixture wire can pose a fire hazard or electrical shock hazard. Therefore, it is essential to have a qualified electrician perform any electrical work. In summary, the NEC permits the use of 14 AWG or larger fixture wire on 20 Ampere branch circuits. This allows for the direct connection of lighting fixtures and other appliances that use fixture wire internally to standard branch circuits. However, it is crucial to ensure that the fixture wire meets all applicable requirements, including the wire gauge, temperature rating, insulation type, and ambient temperature. Additionally, all connections must be made properly and in accordance with the NEC and local electrical codes. By following these guidelines, you can ensure a safe and reliable electrical installation. Remember, always consult the latest edition of the NEC and local electrical codes for the most up-to-date requirements and interpretations. Electrical work can be dangerous, so it is always best to hire a qualified electrician to perform any electrical work. This explanation should provide a clear understanding of the rule regarding fixture, wire, and 20 Ampere circuits. It's important to stay updated with the latest electrical codes and best practices to ensure safe and compliant electrical installations.